Hi students, let's look at this question here which was taken from the year 2016 ACJC mid-year. Question 4, this question is on parametric equation. Let's see how I can do this proficiently. So the curve C has a parametric equation of x equals to 3. So this is x equals to 3 minus 2 cosine t. Then y equals to negative tangent t, right? So what you need to do is actually for this expression here 0 to pi over 2, using differentiation, show that C does not have any stationary point. So if you want to show that C doesn't have any stationary point, what you need to do is actually dy dx. dy dx cannot be equal to 0. Okay, so this case here, we're going to put that dx dt will just be negative 2 negative sine t, and dy dt will just be negative secant square t. Okay, so dy dx on the other hand, dy dx will just be dy dt over dx dt, right? Which is positive. So this case here, if I were to rearrange this, it will be 1 over 2 sine t cosine square t. Alright, so this expression here, obviously, since this one cannot be equal to 0, because top is 1. Equals to 0 meaning top has to be 0, right? But because denominator, you can't let it be 0, it is not going to 0. So since dy dx cannot be equal to 0, hence C doesn't have any stationary point. Yes, that's okay. Okay, then for part 2, let's look at part 2. A point Q has this parameter t pi over 2. Find the equation of tangent Q, leaving your answer in exact form. Okay, great. So at t equals to pi over 6, right? What we need is actually x. We need to find x equals to 3 minus 2 cosine pi over 6. This is exact form. So how do we find exact form? This is cosine 30. So cosine 30 is actually root 3 over 2. Okay, I mean cosine 30 are root 3 over 2. So this is root 3 over 2, and this will just give us 3 minus root 3. Now if you've forgotten that this is exact form, you can actually use your GC to find. So what you can do is actually just make sure it's in radian mode, then you just use cosine pi over 6. Alright, then this is a gibberish. You can either remember this as root 3 over 2 or just square this, and this is actually pi over 6. This is 3 over 4. So square root 3 over 4 is root 3 over 2. Okay, that's good. So then y will just be negative tangent pi over 6. So 30, tangent 30 will be 1 over root 3. Okay, so this is negative 1 over root 3. Okay, so tangent 30 degrees, so pi over 6 will be 1 over root 3. Okay, so that's how you see that. So this done already, and you know that dy dx is a gradient of tangent, which will be negative 1 over 2 sine pi over 6 and cosine pi over 6 square. Okay, sine pi over 6 will be half, then this will be root 3 over 2, 60 square root, then this will just be 1 over 3 quarter, and this will be negative 4 over 3. Okay, so hence equation of tangent, let me just write this at the side because this is like that. Okay, equation of tangent will be equation of tangent. Okay, we're going to use y minus y1 equals to mx minus x1. Equation of line, that will be y minus 1 over 3 equals to negative 4 over 3, x minus 3 minus, and that will give us negative 1 4 over 3 x, and that will be, this will be y plus 4 over 3. This is minus 1 over root 3. 1 over root 3 is 1/3 root 3. The reason why I'm changing to root 3 is because there's a root 3 here. Can simplify this. And what we'll get is actually very quickly, this case here will just be negative 4 over root 3 plus 4 minus 4 root 3, 4 3 root 3 minus 1/3 root 3. So this is like negative 1/3 and negative 1/3. You add it will be negative 5 over 3, right? So it will be 1 over negative 4 over 3x minus 5 over 3 root 3. That's equation of tangent. There you go. So that's how you do the first part. Let's look at the second part. Find the Cartesian equation of locus of midpoint of this and this as t varies. Midpoint, what we need is actually just the locus. So part 2, let's do it. Midpoint is, what we need to do is just add both of the x1 and plus x2. Midpoint is x1, x2 over 2, y1 plus y2 over 2, right? So this case here, what we'll get is actually 3. So this case here will be, just do the as per normal. So this is 3 minus 2 cos t plus minus 3 plus, right, 2 yeah, plus minus 3. So you just take this and add with this one, then after which you have got divided by 2 negative tangent t plus 0 divided by 2. Okay, so there you go. This is it. So the locus just means the governing here. So once we done that, we get negative cosine t. This is negative half t. Alright, so now we need the Cartesian equation. This case here, this is a parametric equation, meaning x, this is my x, this is my x, right? So this is actually x comma y. So in other words, what we have here is actually just x equals to negative cosine square t, y equals to negative half tangent t. Alright, then what we need to do now is just need to we need to find a formula which relate both of them. So how do we find a formula which relate tangent t and cosine t? There's one particular formula which is, we know we can actually change this to secant, right? So really x, actually, okay, let me just do 1 over secant t. Okay, tangent, they are very closely related, so secant t is equals to minus 1 over x. Okay, this is 1. Then tangent t is equals to negative 2. Why do I need this? Actually, there are many ways you can do it. You can draw triangle or whatnot, but here, what we can do is actually just let, we know that 1 plus tangent square t is equals to secant square t. So I'm going to just relate these two, and I'm going to get 1 plus minus 2y square equals to negative 1x square. Okay, so this is 1 over x square, such. So once this is done, I think it's pretty okay. Once done, we're just gonna make y the subject if you want to. So 1 plus square equals to 1 over x square. Okay. Today one as t varies, right? Fine. So this case here, what we can get is actually this is the Cartesian form. You can just leave it like that, it's fine. Or if you do not want to, you could just make y. They never say make y the subject. So 1 over x square minus 1. This will be 4, and after which y square equals to 1 over 4, 1x square minus 1. Alright, so this case here will be y equals to plus minus 1 over 4 if this subject. It's pretty okay. Now I need to whether y is positive or negative, but you look at y here. The y, this cosine square theta, cosine square theta here, sorry, not the cosine square, is a negative tangent t here, negative tangent t and 0 here. we can just actually see what is this value here. We add that up. Will it be a positive number or negative? But this is in the first quadrant, right? So this is actually a negative number. So we should reject the negative one, because when we look at t is actually, this is our y, right? So t is the first quadrant, 0 to pi over 2, meaning to say tangent t in the first quadrant is obviously positive. Okay, it's positive. And once so positive, if you put the negative half, y will be negative, right? So y will be less than 0. So we are getting the negative 1 here. So the equation of the what do you call it, line here, this is very important. We are taking the so this would be just square root 1 minus x squared over x. Okay, now but the problem here is this, I'm not sure how particular they want it to be, because graph here, the x has to be a negative x, because this has to be negative. You see this x here is negative. So when we plot out the, now this is what's going on. This is actually the parametric form here, and you want to find this midpoint between this point and the here. You realize that actually what happens is the y value that we found here is a negative one, which is correct. If we don't take the positive one, will be the one on top, which is not what we want, right? We want the one which is the one below. But when you draw the negative one, actually what happens, there are two curves at play also as well. So actually there's the x positive and x negative. So actually what we need here is to make sure that x is negative, right? So let's look at the midpoint is here, right? You can see that as you travel along, the midpoint is between this point and this point, is traveling along here. So as you go down here, right, there is tracing here. Do you see that, the midpoint? So yeah, so this is the locus point. So we're taking the one on the left, not the one on the right. So how do we decide that? We can actually just put x where x is less than 0. Okay, so this is important, but I don't think they want to be so specific. This will be an answer. Yeah, any question or comments, please keep practicing, and I'll see you in the next question.